Assalamualaikum and hi. We are from Group 21. We will be present about linear regression, which is interpreting the regression coefficient and coefficient of determination. This is our team, which is my name is Sharifah Nur Shahazinani binti Said Jafri. I will present about interpreting the regression coefficient. Introduction to linear regression. Linear regression is a statistical method to study the relationship between an independent variable, which is x, and a dependent variable, which is y. It predicts y from x using the least square method, which is find the best fit line by minimizing the difference between actual and predicted value. It extends correlation analysis, but here x and y are not interchangeable. The equation is y equal to a plus bx. How to find a and b? Just use this formula and the detail is here. In the linear regression equation, we have two key coefficients, which is a and b. A, which is intercept, value of y when x equal to 0, the starting point where the line crosses the y-axis. For the b, which is slope, show how much y change for every 1 unit increase in x. If b greater than 0, it's called direct relationship, as x increase, y increase. If b less than 0, it's called inverse relationship, as x increase, y decrease. If b equal to 0, it is no relationship.
And I will continue from here. As mentioned earlier, multiple linear regression is used to predict how dependent variable change based on two or more independent variables. In this slide, we can see the general formula for multiple linear regression. Now, let's look deeper into understanding multiple linear regression or MLR. MLR helps us analyze the relationship between one dependent variables and multiple independent variables. It is especially useful when we want to see how several factors together influence an outcome. The model assumes a straight line relationship between the variables. However, for MLR to be valid and accurate, there are several key assumptions that must be made. Now let's go through the 5 main assumptions of multiple linear regression. First, there must be a linear relationship between the dependent variable and the independent variables. This means the change in the dependent variable can be explained in a straight line manner based on change in the independent of variable. Second is the independent variables should not be highly correlated with each other. This is to avoid multicollinearity, which can affect the reliability of the coefficient. Third is the variance of the residual must be constant across all the levels of the independent variable. It means the spread of the error should be even. Fourth is the observation must be independent from each other. In other words, the outcome of observation should not influence another. And lastly is the residual should be normally distributed with a mean of 0 and constant variance. This ensures that the model predictions are unbiased and reliable.
Hi, my name is Siti Nurul Nur Syafiqah. This is my turn to explain what is the coefficient of determination R square or the known as R2 and why it is used. What is a R square is a number between 0 and 1 that show how well a model explain or predict the outcome. It's a dependent variable. Understanding R square coefficient of determination. R square show how well the model explain the outcome. R square equals 0, so the model explain nothing, just like guessing the average. R square between 0 and 1, the model explain some of it, better than guessing but not perfect. R square equal 1, that was the perfect number, the model explain everything. So here we already showed the example predicting exam score from the study time. R square equals 0, so the study time does not help at all. If R square equals 0.6. So that means the study time had its a bit. If R square equal 1, study time fully explain the score. Bottom lines close to 1 equal better prediction.
So now that we know what coefficients of determination is and how it is applied in regression analysis, we can now calculate the coefficients of determination using two methods. The first method is by using the correlation coefficient, where the formula is given as r capital letter square equal to r lowercase square, where r lowercase is Pearson correlation coefficient. The method can only be applied in simple linear regression model where there is only one and only one independent variable. So for example, we can use this formula where r is given as 0.6. So r lowercase square is equal to 0.6 square. Then we will get r capital letter square equal 0.36. So when we interpret the result, we find that 36% of the variance in the dependent variable outcome can be explained by the independent variable. The second method that we can apply to calculate coefficients of determination is regression outputs. This method takes information from a regression analysis that we had done to obtain two information, which is RSS, which is defined as residual sum of squares, and TSS, which is total sum of squares. And therefore, we can obtain the formula R square equal 1 minus RSS over TSS. This formula can be applied to a variety of models, including the MLR model, where there is more than one independent variables. So the example, we had obtained RSS and TSS. RSS equals 629.22 and TSS equal 2187.04 from a regression analysis. Therefore, using the formula that I had mentioned earlier, we can then apply the number that we had obtained and get R square equals 0.71. When we interpret R square, it will tell us that 71% of the variance in the dependent variable outcome can be explained by the independent variables or variable.